Hey everyone, it is Mr. Vargas back at it once again for Math 3, working on homework 6.4. Today's topic is common logarithms. Now, before we go any further, let's first talk about what a common log is. So a common log is just a logarithm in base 10. So since 10 is, our pretty standard number system, we work in base 10 quite often. That is the common logarithm because we use it so much. So instead of writing something like this, log base 10 of x, we often just write that as log of x. So we don't even need to have this 10 for our base. If you don't see a base, if you don't see a number down here for your base, you can assume that it is in base 10. Alright, so when you go to type something into your calculator, all you have to do is hit that log key, and it automatically assumes that you are working in base 10. Okay, and that's pretty much what we need to know about common logs. So now that we got that, let's go ahead and check out some of the homework examples. The first set of problems just basically have you punch in log into your calculator and see what it gets you. So for like number 4, for example, you've got log of 5.8, and this is the common log, base 10. There's no 10, we don't see it there, but we know it's assumed. So log base 10 of 5.8. Once again, you're asking what is the exponent. When you plug this into your calculator, 5.8, it's going to give you that exponent. So let me do that really quickly. And here for the problem set, they want the answer rounded to the nearest 10,000th, which is to 4 decimal places. So for this one, it would just be equal to 0.7634. And once again, I just got this from my calculator. If you don't have a graphing calculator at home or a scientific calculator, feel free to use Wolfram Alpha. If you do use Wolfram Alpha, you'll have to type in something like this: common log, and then you would put 5.8. This is what you would type into the search engine, and it should produce this answer. Okay, let's go on to the next set of problems, which have you solve equations based on what we know about common logarithms. So let's check out number 7 really quickly. We've got 4 to the 3x is equal to 12. Okay, so these are kind of fun. What we're going to do is we're going to actually apply the logarithmic function to both sides. And this has to do with something called the logarithmic property of equality. Okay, so if I apply the logarithm to this side, so let's say I apply the common log to this side, then that means I need to apply the common log to this side as well. So now what happens is the log base 10 of 4 to the 3x, if you remember the power property, we can actually just bring this exponent down out front. So it becomes 3x log times log of 4, and all that is equal to log base 10 of 12 on the right hand side. Okay, so once again, that was just the power property. Okay, so now I can actually divide this side, divide the left side by log 4 and get that, and then also I can divide this side by log 4. Since these are in the same base, these are common logs in base 10, then that is perfectly acceptable. So now I've got 3x is equal to log 12 over log 4. Alright, using a calculator, let's simplify this right hand side. That gets us about 1.792 if we round. Alright, and then just go ahead and bring down 3x. Now we can divide the left hand side by 3, divide the right hand side by 3, so x is approximately 0.5975. So 0.5975. Okay, and that is your approximation for x. Alright, let's try one more like that. How about number 13? Looks like a thank you, Teddy. And for this one, we've got 3.6 raised to the 4x minus 1, which is equal to 85.4. Okay, once again, we can apply the logarithmic function to both sides. So we're going to log this side, and we're going to log this side. What happens with the log on the left side is that our exponent gets to come down as just 4x minus 1 times, now we've got log of 3.6, and that's equal to the common log of 85.4. We can divide both sides by the log of 3.6. Okay, good. And this works. We're allowed to do this because these are both common logs. They both have the same base 10. Alright, so now what comes down is 4x minus 1, and that is equal to, let me use my calculator really quick. Sorry, not equal to, approximately 3.4720. Alright, let's add 1 to both sides. Scroll down. Add 1 to this side. Okay, that cancels out, and you've got 4x is approximately 4.4720. Divide both sides by 4. Divide by 4, and you get x is approximately 1.118. Alright, and that's that. Alright, for the next thing, on the next page, we actually get introduced to something called the change of base formula. So we know what a common logarithm looks like. That's base 10. So what happens if we have something in a different base? We can actually use the change of base formula to rewrite that thing in base 10. So here is the rule. It says for all positive numbers a, b, and n, where a does not equal 1 and b does not equal 1, then here's the kind of the payout. The log base a of n is equal to log base b of n divided by log base b of a. And more often than not, we are going to be using a 10 for this base, or the common log. We don't really need the 10 there, but it's the common log. Okay, so let's put some practice to this. I know this can kind of be a little bit confusing at first. Hopefully it makes more sense with some examples. So number 1. Actually, let's jump to number 3. Number 3, they ask us to express each logarithm in terms of common logs, then approximate its value to the nearest 10,000th. So for number 3, we've got log base 5 of 35. So how can we rewrite this in terms of the common logarithm, common base? Right now you'll see it has a base 5. We want it as a common log. All you have to do is just know that this is going to be equal to log of 35 divided by log of 5, with these being the common logarithms. That's it. Then you just go ahead and plug that into your calculator and you should get a nice answer. Alright, let's jump down to number 6 and we'll wrap this video up. Number 6 asks us to evaluate the logarithm of base 2 of 50. So, this is in base 2. We can rewrite this using the change of base formula as log base 10, or the common log of 50, divided by the common log of 2. Once again, there is no 10 here because it's just assumed. That's the common logarithm. Let's plug this into our calculator really quick. And what you get is that this is approximately 5.6439, and that's it. So not too bad. Hopefully you guys kind of understand how the change of base formula works. If not, we'll go over some more of this in class. Good luck and see you next time.